Hey folks, Mrs. Lusardi here. I want to review a topic that we learned earlier in the year. We spent a chapter on naming and formula writing for various types of compounds, and one of those types was acids. So we're going to review naming formula writing for acids. We're studying acids and bases in this chapter, so I wanted to review this. Bases are named like ordinary ionic compounds. NaCl is sodium chloride. Sodium connected to the chloride ion. NaOH, a base, is sodium hydroxide. Sodium connected to a hydroxide ion. But the naming for acids is different. All acid formulas begin with the element H. And the number of H's in the formula depends upon the charge of the anion it's connected to. It could be -1, it could be -2, it could be -3. So if it's -1, we need one H. If it's -2, we need two H's, etc. So let's start with binary acids. Bi means two. So binary acids contain hydrogen and one other element. And we use a two-word name for binary acids. And the naming format is what I call hydroblankic acid. So all binary acids will be hydro something-ic acid. And the something is basically what's the other element it's connected to. So HCl, it's connected to the chloride ion, but we don't say hydrochloride acid. All acids change to ic. So it's hydrochloric acid. HBr, the hydrogen is connected to bromine, so it's hydrobromic acid. And there are only about 5 or 6 true binary acids, so you don't run into that many of them. There are a lot more of what we call oxo or tertiary acids. These acids almost always contain oxygen as part of a polyatomic ion. We also use a two-word name for these oxo acids, but it does not begin with hydro. It's not hydrosulfuric or hydrosulfurous. It's just sulfuric or sulfurous. So the name is based on the name of the polyatomic ion, but we don't use it exactly the same. So H2SO4 is not called sulfate ion. It's called sulfuric acid, or not called sulfate acid. It's called sulfuric acid. H2SO3 contains the sulfite ion, but it's not called sulfite acid. It's called sulfurous acid. So to help remember this, I made up a fake disease. You heard of appendicitis? Well, I say that oxoacids have adic-itis. What does that mean? It means that if the ion ends in ate, the acid ends in ic, and if the ion ends in ite, the acid ends in us. So if you can remember adic-itis, that should help you name tertiary acids. So when there is oxygen present, when it is a tertiary acid, we do not use the prefix hydro. That is reserved only for binary acids. In general, it's one syllable. Sulfate would become sulfic, but with sulfur and phosphorus, they decided that it must sound better if we actually use two syllables. So it's sulfate, but sulfuric, phosphate, but phosphoric. All the others are simply chop off the ate, change it to ic, chop off the ite, change it to us. So here's an example. HNO3 contains the nitrate ion. Its name is nitric acid. Ate becomes ic. H3PO3 contains the phosphite ion. So the ite changes to us, but we do keep that extra syllable. It's not phosphus, it's phosphorus. Given a name, how do you get to the formula? Well, it's kind of like icate, usite. If the acid name ends in us, you must find the nitrite ion on your ion sheet. Its formula is NO2 with a -1 charge, so the formula of the acid is 1H-NO2. Phosphoric, you're not going to find phosphoric on your ion sheet. You have to look for phosphate on your ion sheet. When you do, you find that it is PO4 with a -3 charge. You must balance charges just like we do for ionic compounds. So each H is +1, PO4 is -3. So the proper formula is H3PO4. Okay. So that wraps up our review of acid naming and formula writing. Your assignment is to complete assignment acid 4B, which is to practice naming and formula writing of acids. So no questions to answer in this video, but you must complete homework 4B. Does that sound all right?